Hi guys, this is Mrs. Bolin with your Unit 9 review. So I'm just going to jump right in here. No warm up, no notes today, just a review. So number 1, we have 2 3s and then we have 4 3s. So altogether that is 3 to the 6. And so remember that if we have numbers, we usually try to simplify those if we can. And so I'm going to go 3 times 3 is 9, times by 3 is 27, times by 3 is 81, times by 3 is 243, and then times by another 3, I'm going to get my calculator out for that one, 729. So equals 729. And then for question number 2, we want to distribute, and distribute's the wrong word, but this power to a power we multiply, so k to the negative 12. And then remember, we only want positive exponents in our answer. So remember that negative, it means instead of multiplying by that many k's, we're actually dividing by that many k's. So it's kind of like the reciprocal. So we would just take it and move it to the bottom. And now it's a positive 12 because we're dividing by 12 k's. You can also think about if it's negative and unhappy on the top, we move it down to the bottom and now it's happy and positive. So question number 3, we're going to do a power to both of those. So I multiply the exponents and then I leave it as a quotient. So I would have r to the 12 over t to the 6. So I'm just multiplying 4 times 3 and 2 times 3. And since they are different letters, I cannot reduce them at all. So I just leave it like that. Okay, number 4, remember this 5 goes to everything in there. So I know that there are 5 2's and there are 5 x's. So I'm going to do the 5 2's. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So I have 32x to the 5, and you can totally use your calculator for that. That's okay. If you have a Chromebook, it's just down in that little circle in the bottom left. All your apps should open up, and there's a calculator built right into your Chromebook. Okay, question number 5. Oh, I forgot to box my answers. Okay, number 5, anything to the 0 power. You guys should know this by now. 1. Easiest problems, right? Number 6, I have a 5 in it. That 5 has its own little exponent. This 4 is only stuck to the y. So the 5 stays where it is. It has an exponent of 1. We don't write it when it's just a 1. And then if we have 4 y's, but it's divide by y's, that's what that negative means. So I'm going to put a y to the 4 in the bottom of the fraction. Okay? Pretend like those are nice square boxes, okay? Looking at number 7 now, we need to look and see, does this represent growth or decay or neither? Well, this one was times by 3, times by 3, times by 3. So this is exponential growth. And the rate of change was, or not the rate of change, sorry, the common ratio was 3. So looking at number 8, I'm going to start with the easy ones here. This was divide by 11. So I'm thinking this is also divide by 11 and divide by 11. And so this is decay because it's decreasing by the same ratio. Looking at number 9, our initial amount, A, would be 3. This one, because it is greater than 1, we're always comparing to 100%. If I wrote this as a decimal, or sorry, it is a decimal. If I wrote this as a percent, it would be 188%. So I would say, well, that's definitely above 100%. So this is growth. And I'd say, well, how much is it above 100%? It is 88% above, so, or you could write 88% growth. Okay, number 10. We are going to graph this one. So we're just going to plug in the values. If you've watched any of my other videos, I like to start with the easy ones first. So I'm just going to plug in 0, and I know that anything to the 0 power is 1. 5 to the 1 power is 5. 5 to the 2 power is 5 squared, which is 25. 5 to the negative 1 would be 5 to the negative 1. Remember, that means divide by 1/5, so it would be 1/5. 5 to the negative 2 would be divide by 2 5s, which would be 1 over 25. And so we're going to graph those now. I can tell, looking at my graph, I'm going to run out of room pretty quickly if I go by ones. So I'm going to go by 5s on the y-axis. So I'm going to go by 5, 10, 15, 20, 25. I'm still going to go by ones on the x-axis. So I'm going to go over 0 up 1, over 1 up 5, over 2 up 25. And then in the negative direction, I'm going to go negative 1, 1/5, and negative 2, 1/25. So it's getting closer and closer and closer to that line of 0, but not ever crossing it. But that's what we have. It is indeed growth because this 5 is greater than 1. It's growing very quickly. That's why our scale here was so big. Okay. Looking at the next one, I know that this one's going to be going down or decaying, getting smaller and smaller and smaller each time because this value is between 0 and 1. It's a positive value that's smaller than 1. So I know I'm going to be chopping my answer smaller and smaller and smaller every time. Okay, so if I start by plugging in 0, 2 times 1/4 to the 0, this 1/4 to 0 is just 1. So if I'm multiplying 2 times 1, I just get 2. This one right here, 2 times 1/4 to the 1 would be 2 times 1/4, which is the same thing as divide by 4. And if I reduce that, I would get 1/2. And then if I have 2 times 1/4 squared, that would be 4 times 4 is 16. So I would have 2 over 16. And if I reduce that, I get 1/8. Okay. Going this way, remember that when we have a negative exponent, it means to do the reciprocal. So these ones are actually easier when we have the negatives because 1/2 reciprocal, like the reciprocal of 1/2, if we flip that, we get 2 times 2, which is just 4. Oh, sorry, you know what? That's what I did wrong. This is a 4 and I wrote a 2 down there. So 2 times 4, which is 8. Wondering why my pattern was off. And then I have 2 times 1/4 to the negative 2, which just means we're going to flip this over and get rid of that negative there. So 2 times 4 squared would be 16 times 2 is 32. So again, I'm not going to have room for all of these numbers on my graph. So I'm going to have to go by 8-ish, I think 8. So let's go 8, 16, 24, 32. And I'm going to graph this now. So -2, 32, -1, 8, 0, 2, and then I've got a 1/2 and an 1/8. So it's getting closer and closer and closer to this line without ever touching it. Okay, and then our very last one here is our compound interest. So we put $1,000 into an account, and I'm going to keep 100% of my money, but every month I'm going to add a part of 1% to it. This one says we're earning 1% interest every month. So it's not really saying that we're earning 1% annual interest compounded monthly. So the correct way to write it, the way that this is worded, is y equals 1,000 times 1.01. So starting at our 100%, going up by 1 and doing that every month. So we would get 1% every month. So that's what that should look like. And make sure that you ask your teacher if you have any questions. Okay, have a great day.